We have been learning about the basic quantum circuit calculations, so now we'll be learning about the optimization problems using BlueCat. Today we'll be learning about the Ising model. Ising model is a model that represents a lattice of sites where each site can be in one of the two states, that is -1 and +1, and exhibits a phase transition. We are going to use this equation where E is the cost function, Q is a qubit, so the value of the spin at a specific lattice site where the spin is pointing up that takes +1 is Q0, and where the spin is pointing down that takes -1 is Q1. The final value of Q tends to take the value to minimize the cost function. Now we are going to calculate this equation using the Ising model matrix. The matrix has the coefficients of the above equation. First, we have to prepare the 2x2 matrix because now we have Q0 and Q1. Next, we have to put the coefficients of Q0 and Q1 on the diagonal element. Since the coefficient of Q0 is 1, we put 1 on the first diagonal element. And then we have to put the coefficient of Q0 times Q1 on the off-diagonal element. Since the Ising model matrix is a symmetric matrix, we don't need to put the value on the lower part of the off-diagonal element. Now we are going to continue by using BlueCat in Google Colab. Before that, we shall be doing the coding in the Google Colab. First, we need to install BlueCat. In order to do that, type in !beep install BlueCat in Google Colab. Now let's do it in the Google Colab. Type in !beep install BlueCat. Run this. We can see that the BlueCat gets installed. To represent the Ising model matrix, we have to import opt module from BlueCat and initialize A to store the matrix. Now we'll put the Ising model matrix. Then we'll calculate it, but this time we'll try using 100 times. When we run all this, we get this output where 0 is read as -1 and 1 is read as +1. Let's try it out in Google Colab. We'll run each lines of code one by one. Run this. We can see that we get the same output. This is a simple demonstration on Ising model. Thank you very much for watching the video.